Welcome everyone to the practical demonstration on the characteristics of Zener Diode. In this session, we will explore the key features and the behaviors of Zener Diode, a specialized type of diode which is used for voltage regulation and protection in electronic circuits. So let's begin with the experiment. Here we are using the digital apparatus of Zener Diode characteristics, which is having inbuilt voltmeter and milliammeter, inbuilt power supply, inbuilt connected resistance and a Zener diode, which is indicated by symbol Z1, Z2 and Z3. Here we are having 3 diodes. There is black knob in between voltmeter and milliammeter, which will decide the scale of milliammeter, whether you are taking 15 milliampere scale or whether you are taking 1.5 milliampere scale. So now let's find the least count of these meters first. Have a look on ammeter. Here in the device we are using milliammeter, and we very well know that 1 milliampere is equals to 10 raised power minus 3 amperes. So this ammeter comprises of 2 scales. It depends on us which scale we use, whether the upper one, that is of 1.5 milliampere, or the lower one, that is of 15 milliamperes. We can choose the scale depending on our need by using the knob discussed earlier. Now we will show you the least count for both the scales. Now depending on your need, you can choose the scale. First of all, we will find out the least count for the upper scale, which is of 1.5 milliampere. Here in this scale, we can see 10 divisions are showing the value 0.25 milliampere. So the value of one division will come out to be 0.025 milliampere. So the least count of the scale came out to be 0.25 milliampere. Now this scale was of value 1.5 milliamperes. Now proceeding for the next scale, which is having the range of 15 milliampere, that is our lower scale. Here in this scale, 10 divisions are equal to 2.5 milliamperes and one division corresponds to 0.25 milliampere. So this is the least count of our specified 15 milliampere range ammeter. Proceeding with the same method, we will find out the least count of a voltmeter. Just have a look on voltmeter. Now we are finding the least count of the voltmeter. We can observe here that 10 divisions of voltmeter scale corresponds to 2.5 volt. Thus, one division will correspond to 0.25 volts. So this is the least count of our voltmeter scale. Now let's start making the connections. Based on the circuit diagram, connect the equipments. Here the red terminals indicate the positive polarity and black terminals indicate the negative polarity of a device, but no end of resistance has positive or negative polarity. Let's start making the connections. After making the suitable connections, switch on the inbuilt power supply. Adjust the value of potential from the rheostat and verify whether the circuit is working or not by checking the deflection in both the meters. Now adjust the scale of ammeter to 1.5 milliampere by using the black knob. As in the reverse biasing conditions, diode allows the passage of only small current. Now we will make an observation table between voltmeter reading and an ammeter reading. See, up to 10 divisions of voltmeter, my ammeter is giving you 0 reading. So after that, on 13th division of the voltmeter, my milliammeter is pointing at the first division. Note down this reading in the observation table. Using the same method, we have obtained the second reading, that is 16th division of voltmeter is coinciding the 5th division of milliammeter. Based on the number of observations, we have obtained the following observation table. Based on the observation table, this is the obtained graph, and the value of Zener breakdown voltage came out to be 4.5 volt. So that's all for today. See you again, students, in the next video. God bless you all.